what is a frequency histogram in statistics? A frequency histogram is a bar graph that represents the frequency distribution of data sets. A histogram has the following properties. First of all, the horizontal line is quantitative and measures the data entries. So here on the horizontal line, you have prices. The vertical line scale measures the frequencies of each class. So here you have count or frequency of each prices in the horizontal line, but we divide it up into 7 bars or 7 classes. And finally, consecutive bars must touch. There is no gap between these bars. So let me show you how to graph a histogram in statistics and then using Python. Suppose you collected the information about the data set that has the prices in dollars of 30 portable global positioning system GPS navigators. We're going to construct a frequency distribution that has 7 classes, everybody. So this 7 is important. Take a look at your data. $128, $230, $132, $90, $112, $90 again, $340, $85, $200, and so on. As you can see, the data is not organized. What are we going to do? We're going to follow some guidelines. First, decide on the number of classes to include in the frequency distribution. The number of classes in this example is given to us as 7. If it's not given to you, then you should select a number between 5 and 20. In the second step, find the class width, which is the range divided by the number of classes. So you find the range, which is maximum minus minimum, and divided by the number of classes, and then round that number up. That is going to be your class width. In the third step, find the class limits. You can use the minimum data entry as the lower limit of the first class. To find the remaining lower limits, add the class width to the lower limit of the preceding class. Then find the upper limit of the first class. Remember that classes cannot overlap. In the fourth step, make a tally mark for each data entry in the row of the appropriate class. And in the fifth step, count the tally marks to find the total frequency, which is denoted by F for each class. So let us begin. We're going to find the range. The range of the data is 340, which is the maximum value in your collection, minus 65, which is the minimum value in your collection. So this is going to be your range. Now, to find the class width, divide the range by the number of classes. We did the algebra, 275 is the range, divided by 7. Where did 7 come from? The question says you need to have 7 classes. The number that you get is 39.29. Now you need to round it up to 40. Next, let us construct a nice table with tally marks and frequencies. Remember, to find the class limits, you can use the minimum data entry as the lower limit of the first class. So the lower limit of the first class is 65. This is the minimum value in our collection. For the second class, 65 plus 40 gives you 105. So since the lower limit of the second class is 105, the first class stops at 104. So there is no gap between these two beans or classes. Now, count how many 65, 66, 67, 68, 69, and 102, 103, 104 you have in the first class. If you find them, you can take a look. You have a 65 here. Then I'm just take a look at this. You have 100 here. Then you have 90 here, not 105. You have 85 here. Then you have 80 here. Take a look. You have, let's look for all of them. You have a 90 here. So you have 1, 2, 3, 4, 5, and 6. So the tally mark shows 6 tallies, and then the frequency is 6. For the second class, you're going to start counting how many 105 you have, how many 106 you have, and you continue this process and you stop at 144. If you count the number of prizes in the second class, you see you have 9 prizes in the second class. And then for the third class, remember that 105 plus 40, which is your class, it is 145. And here you stop at 184. And if you count the number of tally marks, is going to be 6. The next class starts at 185 and stops at 224. You could just add these together as well. 104 plus 40 is 144. 144 plus 40 is 184. 184 plus 40 is 224, and so on. You can basically construct a nice frequency distribution with frequency which are listed all here. If you add them all together, this summation means addition, it must be 30. How many data do I have? I have 30 portable global positioning system or GPS navigator prizes here. So when I add all of these frequencies, it must add up to 30. Now what? Now we're just repeating what we did before. And then our next step is to find the midpoint, relative frequency, and cumulative frequency for each class. To find the midpoint of each class, you're going to take the lower limit and add it to the upper limit divided by 2. To find the relative frequency, you're going to take the class frequency and divide it by the size, f over n. And the cumulative frequency of a class is the sum of the frequencies of the class and all previous classes. Take a look. For the first class, I have 65 to 104. The frequency that we calculated was 6. The midpoint, I'm taking 65, I'm taking 104, add them together and divide it by 2. The midpoint, or the representative for the first class, is 84.5. Relative frequency, the frequency of the class is 6 divided by the sample size. You had 30 prizes in your collection. 6 divided by 30 gives you 20% or 0.2. Cumulative of the first class is 6. We don't have any class before this, so you're just going to copy down the frequency as the cumulative frequency. Let us move on to the second class. The second class starts at 105 and stops at 144. The frequency that we calculated is 9. The midpoint, 104 plus 144 over 2 is 124.5, which is the representative of the second class. Now let us find the relative frequency. The relative frequency is 9 divided by 30, which gives you 30% or 0.3. Now to find the cumulative frequency, you're going to add these two frequencies together. It is 15. Let's take a look at another class, 145 to 184. The frequency of the third class is 6. The midpoint, you take the lower limit, 165, you add it to the upper limit and divide by 2. So you get the representative for the third class. To find the relative frequency, this is 6 divided by 30, which is 20%. Now to find the cumulative frequency, we're going to add all of these frequencies together. So it is going to be 21. Take a look at a table that has all of this information here. This is frequency table. It has the classes. It has the frequency for each class, the midpoint or representative for each class, the relative frequency for each class, and the cumulative frequency for each class. If you try to graph this on the horizontal line, you have 64.5, which we use as boundary to make sure there is no gap between graphs. So we are shifting each one of these half a unit to the left, half a unit to the right. 64, half a unit to the left is 64.5. 104, half a unit to the right is 104.5. The height of the first bar is the frequency of that bar. So the first bar stops at 6. The second bar stops at 9. The third bar stops at 6, and so on. This is the histogram representing the behavior of the data in your collection. But how do we use Python to generate a histogram? We're going to use matplotlib, as you are familiar with it, as a nice library of data visualization in Python. You can take a look at matplotlib.org, the page, and look for some documentation for a histogram. If you take a look at it, you're going to see some information about the syntax of a histogram. We're not going to use all of these, but it's a good practice to take a look at the syntax of histogram and feel more comfortable about each one of these arguments. You can find some examples in the web page, a histogram, a sample code that helps you to generate a histogram and generate data and plot a simple histogram. Now for our example, these are the information that we had. First of all, import matplotlib.pyplot as plt. Remember that we are importing the matplotlib.pyplot library and gives it an alias plt for convenience. Now, you're going to create a variable. Let us call it data underscore set and list all of the prices that we have. Next, define the number of beans or classes. Define num underscore beans equals to 7. Why 7? Because the question says, hey, I want to have 7 classes. This variable determines how many classes or groups or beans of the data are going to be available. Now, let us create a histogram. plt.hist, which represents the histogram, open parenthesis. The very first value is the variable including the prices, data underscore set, comma. The number of beans is going to be assigned to beans, 7. And let us use a color for edge, black. You can change this color if you want to. This line generates a histogram using histogram function, or for short, we write it as just hist. From matplotlib.pyplot, it takes your data set, which is the prices that you have, divided into 7 beans or 7 classes. Now, let us define some labels. plt.xlabel, price in dollars. So x-axis has prices. plt.ylabel has the frequency or the count. And then plt.title gives it a nice title. Very good. Now, if you run the code, it generates a nice histogram for you. You can also customize x-axis scale. plt.xticks, which has 80, 120, 160, and 360. What does it do? This line sets the positions of tick marks on the x-axis, and in this example, you're going to choose specific values for better control over the scale. If you run the code, you're going to have this nice histogram, and as you can see, there is no gap between these bars, and it's very similar to what we did in statistics.